Welcome to Ground Control. I want to do a final video of the brushless conversion of the Eachine Mini P47. I think this is the best brushless conversion I've done so far, and I think it's the cleanest brushless conversion that I've done so far. And the reason for that, it's not because I've gotten better at doing brushless conversions, but it's because of the way the airframe is put together. It makes the brushless conversion easier than the other planes I have done brushless conversions on. And the reason for that is you've got your seam on the top that I cut open all the way from where the canopy attaches all the way down, right along the seam in the very front of the fuselage, and on the back from where the wing attaches to it. Of course, you want to remove your wing and your canopy before you cut. Right along the seam on the bottom of the fuselage. And all I needed was a large enough area to pull it apart a little bit to basically rip that brushed motor and gearbox mount assembly out of the fuselage. That was the only reason that I needed to cut that open like that. The fact that the wing bolts onto the fuselage rather than being glued to it meant that I didn't have to cut the wing loose. So that was a much easier process than cutting the wing off and then creating a way to fix it back so that it can be removed again. I didn't have to do any of that work. So that made it much, much easier. The less cutting you have to do, the cleaner it's going to look when you get done. Alright, so in the show notes I have provided a link to the playlist for this brushless, for this Mini P47, which also contains additional videos that I produced relevant to the conversion of this plane. So there's a video on the disassembly of this aircraft to get it prepped and ready for the conversion, and then there's also an assembly video that's related to the brushless conversion of this Mini P47. I have recently published on our Facebook page my setup file and my OpenTX model file for this brushless Mini P47. The setup file also includes the templates that I created for the motor mount, and the OpenTX model file also includes an image of the plane that you can use in your radio, like the one I have, the TX16S, RadioMaster TX16S. Okay, so the other reason that I decided to convert this airframe, why I chose this airframe as a conversion, was not only because mechanically it made it easier to get to the electronics and to remove the stock electronics and install the new electronics. This is a 500mm wingspan plane. This is the minimum size plane I think that I would use for a brushless conversion for a 2S brushless power system. I wanted a plane that was going to be big enough to be able to handle the additional weight of a 2S power system and be able to get the amount of thrust and flight time that I wanted to get out of this once the brushless conversion was complete. And I am completely happy with the results of the brushless conversion and the modifications that I did to it. There are a couple of things that if I had to do it over again I would change, and I'll go over those in just a couple of minutes. But first I wanted to go over all the components that I used for this. And I used the V761 gyro receiver servo brick that came out of my Volantex Sport Cup 500 because I had already performed a 1S brushless conversion of that plane. I replaced the brick, which is the standard low voltage micro receiver, didn't have a gyro in it. So it was just manual mode only. But I saved that brick just in case an opportunity came along later on that I would want to use the brick. So I'm glad I did that. So that is the receiver brick that I used. I did not use the stock receiver brick that was in this plane. I used the V761 out of the Sport Cup 500. I was contacted by J. Bauer Electronics, and he knows that I have performed several brushless conversions of these microplanes. He had developed a brush to brushless module that was specific to that V761 board. And he asked me if I would be interested in testing and reviewing that module. Well, I had planned on doing a brushless conversion of the Mini P47. I didn't plan on getting to it as early as I did. But when he contacted me with information about that module, I thought, man, that'll make a brushless conversion so much easier. And I have the old V761 gyro brick out of the Sport Cup 500. I said, yeah, send me the module and I will set it up and see if I can do a brushless conversion of this Mini P47. So once I received that module, I set aside time to get this project completed. Not as quickly as I wanted to, because life gets busy, but I got to it much, much earlier than I had planned on doing it. All right, so, and the brush to brushless module makes it a lot easier to do these brushless conversions than the way I've done it in the past, because you also have the benefit of having a gyro. You have the benefit of using a receiver gyro brick that has 2 servos on it, so I'm not having to use 2 additional micro servos for the elevator and the rudder. I used the stock servo that was available for the ailerons, that's still stock. And but using the V761 gyro board gave me 2 additional servos to use, in addition to being able to use that brush to brushless module and having the additional, having the gyro. You know, it's nice to have a gyro in there to use, if for nothing more than to save the plane when I run out of talent. I would like to have a gyro for that specific purpose in all of my planes. So that was a win-win-win situation using that brush to brushless module, and I highly recommend it. It worked flawlessly on this project, and I will be using it in the future. The motor is the RacerStar BR 1306 3100 kV 1S to 2S brushless motor. It has been my workhorse for these 2S brushless conversions and on DIY projects. I love that 1306 3100 kV motor for a 2S LiPo setup. It's a fantastic little motor. Gives you good thrust and good efficiency. The prop I paired it up with is a Diatone or a Gemfan. To me, they look identical. I've tested both of them on the bench. They both give me the same numbers, you know, as far as thrust and efficiency for that specific motor. So I use what this prop is a Diatone 5x3 2-blade ABS prop. A Gemfan 5x3 2-blade ABS prop will work just fine. I used a Turnigy Plus 10 amp ESC. Has a linear back that provides 5 volts, 2 amps of power, and it's rated for a 2S to 4S. The LiPo that I like to fly it with, and this is a really old, I wish I had newer ones, but this is a really old Sheeta, or Fully Max. It's a Fully Max 2S, 400 milliamp hour, and I believe that's a 25C LiPo, so it should be able to supply 10 amps of power. It weighs 20.1 grams, and I like the feel of the plane with that 20 gram LiPo in it. I like it better than the smaller 300s that weigh 17 grams. 3 grams doesn't sound like much, but when you're talking about a very small, lightweight plane like this, 3 grams does make a difference. The brush to brushless module, if you guys order that module, in the notes section when you order it, request that the wires be pre-soldered to that module, and they will do that at no additional charge. That will be a time saver. I would take advantage of it. Also, when you purchase that, they should send you a link to the documentation for that module. Don't forget to use that link to download the required documentation, because without the documentation I would have not been able to wire that up to the V761 board. The instructions are very well written, they're very straightforward, they're very easy to understand. The module can be used as a 1S power system, with a 1S power system or a 2S power system. They have diagrams in there to show you the difference in the wiring between a 1S setup and a 2S setup. I use the 2S setup. They have images in there that will show you where the wires are all attached to the module itself, what wires you need to use to attach to the ESC, what wires are attached and where they're attached to the V761 board, including the small diameter yellow wire, which you're going to solder onto the FET gate for the brushed ESC that provides the module with the brushed ESC signal to convert for to a PWM signal for an external brushless ESC. If you follow those instructions and look at the diagrams and look at the pictures, you're not going to have a problem getting that wired up. Because believe me, I'm not an electronics guy. So, and I was able to do it without any problems whatsoever. All right, so the V761 board, the link that I have in the show notes is to the proper version of that board. It's mounted right side up. They do have versions of that board that need to be mounted upside down, inverted. I think on the Mini P51D Mustang, the Eachine Mini P51, I think that board is actually mounted upside down, and the gyro is wired that way. So make sure that you use the link that I have in the show notes for the proper V761 board. It's compatible with the Volantex Sport Cup 500, which is mounted right side up, just so you know that. Using that board did require modification of the fuselage and the control horn on the elevator, because the direction in which that gyro corrects the control surfaces to level the plane, it expects that elevator to move in a specific direction, and you can't change that on those boards. You can always reverse the channel in your transmitter, but that's not going to do any good for the gyro. The gyro expects to level the plane. It's going to move the control surface in a specific direction. I didn't think about that before I started the project. But on that V761 board, it expects the control horn to be mounted on the bottom side of the elevator. Well, on this P47, it's mounted on the top. So the gyro was correcting the elevator in the wrong direction. That makes it unusable. So what I did was I clipped off the control horn, the stock control horn on the top of the elevator, rather than trying to rip it out and damaging the foam. I removed the linkage at the servo and at the control horn, and I routed it through an additional hole, because on the stock setup it comes out the fuselage above the horizontal stabilizer, and you're going to need it to come out below the horizontal stabilizer. So directly below that one, I just drilled another hole and then grooved the foam a little bit so it wouldn't bind the control linkage when it comes through the fuselage. And then I attached another micro control horn right next to the original control horn on the elevator, but on the bottom instead of the top. And then the V761 board is correcting the elevator in the proper direction. So don't forget that if you're going to do a brushless conversion of this specific airframe. Everything else was fine. The control horn on the elevator was on the right hand side, just like the V761 board expects it to be. The control horns for the ailerons were on the bottom, right where it expects them to be. So then once I fixed the elevator issue, everything was correcting in the proper direction. And if you guys have watched any of the demonstration flights, you've seen me. I typically launch it in gyro mode and then switch into full manual mode. So you can see that everything's working as it should. I did have to remove a bit of foam on the inside of the battery compartment so that I could shove the battery as far forward as I needed to get a neutral balance on the CG where the plane just flew really well. You know, it didn't nose up, it didn't nose down, it didn't try to stall on me. It seems to like the CG where I have it with the neutral balance, and it flies very well on that CG, and it is very stable at that CG, and the rolls are very axial and very symmetrical, which tells me that that balance is good too, and it's trimmed out right. So the motor mount I deviated from my original plan. My original plan was to cut 2 plates of that plastic cardstock that I used to glue to the front of the nose of the aircraft, on the nose of the fuselage. And I thought, you know, that stuff is rigid enough and it's thick enough, I could probably just use a single plate. So that's what I did. I just used a single plate to attach to the nose of the fuselage, and that worked fine. The motor is nice and secure on there. So that turned out not to be an issue and saved a little bit of weight. We see the receiver board installation is different than what I planned on doing. I just couldn't get it oriented to a point where I could affix it to the fuselage and be able to remove it later on. So what I did was I just took another piece of the cardstock, I set it, I cut it to the width and the length a little bit longer than the receiver gyro board, a little bit wider than the receiver gyro board, and wide enough that it would sit on top of that foam level inside the fuselage, right where the original gyro board was installed. So I hot glued the receiver gyro board to that plate and then glued the bottom edges of the plate into the fuselage. That way, if I ever need to take it out again, I can just peel the board out of it pretty easily without taking a chance on damaging the receiver gyro brick. And that way, if I need to use it in something else later on, I could still use it with the same type of mount that I've got in there now. So just for your information. I did not measure the angle of the motor that I have in this precisely, but I've done enough of these that I can give you a very good estimate of the angle on the motor. Okay, so just looking at this motor angle, the amount of down angle and the amount of right angle that I have on it, I would say that it has approximately 1.5 degrees of down angle on the motor and 1 degree of right angle on the motor. And that amount of down angle and right angle allow me to fly this plane and do bank and yank turns without having to use the rudder, and it performs those turns nice and coordinated turns just using bank and yank on it. With that amount of motor angle, I get symmetrical rolls to the right and the left, which tells me that it's completely removed the amount of motor torque, you know, from the prop. And it holds its attitude straight and level at cruising speed. It doesn't nose up, it doesn't nose down. So I think that that is a very accurate amount of down angle and right angle on that motor, and it has made it fly much better than it did stock. So that's for your information. I also ended up having to add 2.5 grams of ballast weight on the nose, even with that 400 milliamp hour 2S LiPo that weighs 20.1 grams. In order to get a neutral balance on my CG, I had to add 2.5 grams of nose ballast weight to it. Hate to do that, but it is what it is, and it handles it that weight just fine. You've seen, if you watch the video, you've seen how it does big, huge wide loops. It's got plenty of power, and that gets the CG where it needs to be. Alright, so the dry weight on this without the battery is 98.4 grams. The weight with the 2S 400 milliamp hour 25C LiPo that weighs 20.1 grams puts the all-up weight at 118.5 grams. Okay, and one more modification to the airframe that I made was the ailerons. Now, I knew that it was going to be moving through the air a lot faster with this 2S brushless power system than it was stock with that brush motor and gearbox. I mean, it didn't move through the air very quickly at all. I think it was a bit underpowered in the stock configuration. So I held off on making a modification on the ailerons until I had a chance to put a couple of test flights on it and test the roll rate again. Though the roll rate was much better because it was moving faster through the air, but it was still pretty lethargic. So what I ended up doing with the ailerons is I extended the ailerons by 50 millimeters. So I cut the ailerons completely off. I cut off the additional 50 millimeter extension all the way off. I glued that section to the end of the original section and let that set up. Then I went ahead and took a knife and beveled both the top and the bottom of the aileron. I cut the foam hinges completely off the trailing edge of the wing and the leading edge of the ailerons. I replaced the foam hinges with some plastic micro hinges, and I will put up on the screen a picture of the micro hinges that I used for those ailerons, and also some additional pin plastic hinges that I purchased for doing the exact same thing. You can use either type of microplastic hinge. They both work exactly the same way. For something this size on the pin hinges, I would probably cut about half of the pin off and then install them so that they weren't so long. But I scavenged that I-beam shaped micro hinge from my retired F-86 Saberjet, my 64mm EDF Saberjet. Those are where I got those from. So I used those on those hinges. So now the hinges have absolutely no resistance to them anymore whatsoever. I didn't want that aileron servo to have to work any harder moving that additional 50 millimeters of control surface than it was in the original configuration. And since I've removed those foam hinges so that now it doesn't have any resistance at all, I don't think those servos are working any harder than they were when it was a stock configuration, but they move much more smoothly now. And now it has a really good roll rate. It's not too fast, it's not too slow. I would say that the roll rate that this has now is right there in the Goldilocks zone. The roll rate that I always look for on a traditional plane like this is a 1 second, rotating 360 degrees within 1 second. So you push the stick all the way over 1001, it should have completed its roll, and I think that's right where this one is. That's the speed that I like to see on a roll. Is that quick, but not not faster than that, not slower than that. So that worked out extremely well. On the all-up weight that I was talking about earlier, you would think that 118.5 grams would be kind of heavy for that plane, and that's what I thought too. When I first put this on the scale, even with the 300 milliamp hour LiPo I originally flew it with, which was put it at 115.5 grams, I thought, man, this is going to be too heavy. But it's not. It's still, even at 118.5 grams with that 400 milliamp hour LiPo, it is still light on the wings. I mean, I think in its stock configuration, I think it was just under 100 grams. I think it was like 98.5 grams all up weight with the 500 milliamp hour 1S LiPo. And it was extremely light on the wings then, and it is still light on the wings now. When you're coming for a landing, you can still float it in. So it can handle even more weight. If you wanted to put a little bit larger LiPo in it, this plane wouldn't have any problem carrying it. So I might actually test it with a 450 milliamp hour LiPo. I've got a couple of other LiPos that are just like this, the same form factor, a little bit longer, that are 450 milliamp hour instead of 400. I don't know. I can't remember the weight on it. They're probably maybe a gram and a half, 2 grams heavier than this one is. Okay, so I always like to end a project with what would I do differently. Okay, so here's what I would do differently. The ESC, I put the ESC in the same compartment as the LiPo. I've got the ESC shoved all the way forward and then the LiPo shoved all the way up against the ESC. If I had to do it over again, when I had this nose section split apart to get the stock brush motor gearbox amount out of it, I would cut a little slot in that foam and I would locate the ESC in the bottom compartment instead of the top compartment. Locate your ESC pretty close to the nose in the bottom compartment. Bring your power cable up through that bottom compartment and then up into the fuselage, and then slide your battery in the top compartment so that your ESC and your LiPo you can push as far forward as you need to. If I had done that, I may not have needed this 2.5 grams of additional ballast weight, because then I would have had the ESC and the LiPo all the way forward instead of one behind the other. So something to consider. That would make it 3 grams or 2.5 grams lighter anyway, for a larger battery to put in it. And if you did that, my guess is you wouldn't have to push your battery all the way forward, and it would give you a better way of getting the balance without having to push the LiPo all the way forward. So that's something different that I would do. The aileron mod, now that I know that it's needed even with the brushless conversion, I would do that at the same time that I was doing the brushless conversion. You will be very happy you did, because like I said, it has an exceptional roll rate now compared to what I had to begin with. So I would do that. Instead of using this RacerStar BR1306 3100 kV motor, I haven't tested this on the bench, but I'm just, with all the testing that I've done on motors and props, I'm just betting the BetaFPV 1506 3000 kV motor weighs approximately 3 grams heavier than this 1306. It's going to have quite a bit more torque than this 1306. My guess is it's not only is it going to spin the prop faster, which is going to give you more power than that 1306, but it's going to do it pulling fewer amps than the 1306. And since it weighs 3 grams heavier than the 1306, you're definitely not going to need any ballast weight on there. So you're going to have more power, you're going to have longer flight time, and you're not going to have any dead ballast weight on the nose. To me, that's a win-win-win situation, and I like those. All right, so that concludes everything, all the information I wanted to give you guys. Like I said, there is a link in the show notes to the playlist, and that also has a video in there with the motor, the gyro brick, the ESC, and the brushless module outside of the plane, demonstrating how it works. So there's 3 other videos in there besides this one related to the brushless conversion. So hopefully that gives you guys all the information that you need if you're interested in doing a brushless conversion of this particular airframe or a similar one, because all these components will work on a similar plane. It doesn't have to be this specific plane, but this is the easiest conversion I've done so far. It's the happiest I've been with the results of a brushless conversion, and it's the cleanest one I've done so far. So even if you're looking at a different plane, those components will work fantastic for a 2S power system setup. So anyway, thanks for watching, and I will see you in the air.